Hello, this is Bethany Leone, editor of Heat Treat Radio, stepping in with a quick word about this episode, which is available in full video. Watch and listen to the full length of the episode at heattreattoday.com/radio and look for Water in Your Quench with Greg Steiger. Support for today's Heat Treat Radio episode is provided by the Quench Ebook, high-pressure heat treatment leading the renaissance of hot isostatic pressing. Get it today at www.heattreattoday.com/ebook. And welcome to Heat Treat Radio. If you quench with oil, you'll find this episode particularly relevant. Our guest today is Greg Steiger, the Senior Key Accounts Manager for Idemitsu Lubricants America, and he will be talking with Heat Treat Radio host Doug Glenn about the causes and dangers of water in your quench tank, how to know if you have too much water, and what to do if you do. Let's get started.
Welcome, everybody. This is Doug Glenn, Heat Treat Radio. We're here today to talk to Greg Steiger from Idemitsu regarding really a pretty important safety issue. And not only safety, it can also affect the quality of a product. And that issue we're going to talk about is water in quench oil. So Greg, first off, welcome to Heat Treat Radio. This is the first time you've been on, and I know we've talked about doing this for quite a while, so welcome.
Thank you.
Yeah. So
it's my pleasure.
Yeah, glad to have you. And I asked the question before we hit the record button, but I think we need to ask the question again. The big white flag in the background with the W, you need to tell us about that.
Well, that's the flag that they fly outside of Wrigley Field every time the Cubs win. And they've been doing this for almost a century. So that way, when they were only playing day baseball and you could come home on the L, you could see if the Cubs won or lost without looking at a box score.
That's great. That's great. Now, but you are not in Chicago area, are you?
No, I'm in the Columbia, South Carolina area, but I was born and raised in the Chicago area.
So you're a fan. You're a
Yes,
Cubby fan.
I am.
Being from Pittsburgh, I forgive you for that. Okay. All right. So Greg, first thing, let's have if you don't mind, kind of give our listeners and viewers just a brief background about yourself, and then we'll jump into the water topic, so to speak.
Sure. I got into this industry when I graduated from college in 1984 as a formulating chemist. And I eventually worked my way into what we call customer service or tech service, where I'd go out and visit customers, run product trials. Customers had problems. Worked my way into laboratory management and eventually sales and marketing. And I've been with Idemitsu now for the past 9 years. And since I've been with Idemitsu, I've earned a master's degree in materials engineering. And I've learned a lot about heat treat, and it's really become my passion. And I am the market segment leader for heat treat products for Idemitsu.
Yeah. Yep. And I should congratulate you on that degree, by the way. I know a year or so ago you were still working on that, which is great. That was great.
May 6th, I graduate.
Yeah, very nice. Very nice. That's great. Yeah. Well, yes. And tell us just briefly, for those who might not know, Idemitsu. Which you can see it on your shirt, but we'll spell it out too. But tell us about them a little bit, just so people have a sense.
Idemitsu is a very well-kept secret here in the US. We are actually the 8th largest oil company in the world. We are a Japanese-owned company. There's about an 85 to 90% chance that no matter what vehicle you drive, you've got some of our fluids in it.
Okay.
We have our largest market share is the automotive air conditioning compressor market. But basically, if you drive a Honda, Mazda, Subaru, or Toyota, it left the plant with our engine oils, our transmission fluids in it at the factory. When it comes to quench oils on the industrial side, Idemitsu is actually the second largest quench oil provider in the world.
Huh.
And even though we're Japanese, all of our quench oil products, or all of our heat treat products in general, are made and blended here in the US. We don't import anything from Japan for
Huh.
our heat treat products.
Very interesting. Very interesting. All right. So a big company, somebody worth paying attention to, I think is the point. Yeah, you're right. It's the best kept secret, and we're trying to work to not make it so secret.
We're doing
All
what we
right.
can, Doug.
Yeah, well, we try. Hey, let's talk now. So this next question I'm going to ask you is very, very basic, but and most people on listening, I'm sure will know this, but there may be some that don't. Why is water in quench oil a problem?
A little bit of water is not a problem because it'll happen naturally through condensation. But when you start to get too much water in there, a couple of things happen. Our research has shown that basically above 200, 250 ppm water, you start to get uneven cooling. A quench oil is not a completely homogeneous fluid. So it's possible to have water in one area of the tank and no water in the other. So you can get different cooling speeds in different areas of the tank. And when you start getting up to large amounts of water, somewhere around 750 ppm to over 1,000 ppm, it becomes a safety issue. And what happens is when water turns into steam, it actually expands. Most things, when they get warmer, they contract. But water is the opposite. It expands, and it expands 1,600 times at boiling, and the hotter the steam gets, the more it expands.
Yeah.
So think of it, if you have a gallon of water in a 3,000 gallon quench tank, you boil that water, it turns into 1,600 gallons of steam.
Yeah.
And it's got nowhere to go but up and out of the quench oil, and it's going to carry the quench oil with it and onto flame curtains, other hot spots on the furnace, and that's why it becomes so dangerous.
Yeah. Yeah. It's really the risk of explosion in a sense. I mean, that's basically what we're talking about. And I could be wrong, but my gut feeling is that a vast majority of quench fires are started because of water that happened to, or simply the product not getting down into the quench fast enough. But a lot of it's caused by carrying water in with a part.
Not necessarily on the part, but being in the oil itself.
Yeah.
Through various means. And like I said, it happens naturally. Every time you heat an oil up and you cool it down, you get condensation.
Okay.
But that's usually only a few parts per million. And every time you drop a load in, you're driving that water off.
Right. Right. Raising up the temperature and therefore boiling off the water.
Right.
Right. It's kind of a follow-up question into what we were just talking about, and maybe we've answered it, but where does the water come from? I mean, is it typically just condensation, or what are the top ways water gets into the tank?
Condensation is something we can't prevent because, we live in a hot, humid environment.
Yeah.
But what we can prevent is human error. And that's where most of the water comes from.
Okay.
For instance, if a heat treater has got their quench oil stored outside, perhaps in totes,
okay,
it's very important to make sure that the caps and the lids on these totes or drums are very tight and secure, because otherwise they'll get condensation in there and rainwater in there.
Mm-hmm.
Heat treaters, we've seen instances where people are working on a furnace and they will hit the sprinklers, and the sprinklers will set off and put water into the quench oil. Heat treat, furnace doors, and not so much anymore, but heat exchangers were water cooled.
Yes.
And anything that's under pressure is eventually going to leak. And that's why you see companies going to air cooled heat exchangers. Still more difficult to get that water cool or air cooled door. And there's still some water in those doors. Anything under pressure is eventually going to leak. And that's where you see some of the the water infiltration as well.
Gotcha. How, typically speaking, how warm or how cool is the oil in a quench tank? I mean, is it, because you mentioned about condensation being caused by when it cools down, then you're gonna have some some condensation in there. You have a sense of where do we run those tanks?
It depends on if you're using a hot oil or a cold oil.
Okay.
A cold oil is basically an oil that you add some heat to get it to around 130 to 160 Fahrenheit.
Okay.
And then you use your heat exchangers to keep taking the heat away when you quench the load in there. A hot oil, you add heat to constantly because you want to keep that typically 250, 300 degrees Fahrenheit. Hot oil, you really don't have a lot of issues with water unless the furnace goes down, and then you get a lot more condensation than anything else. Now, a cold oil, you have issues with water because you're not above the evaporation point of the water.
So bottom line is if you've got water, too much water in a quench tank, it's an issue. Tell us about the measurement? How do we know if we've got water in there, and how do we know how much we have?
Well, there are some portable test kits out there made. The ones I'm familiar with are made by the Hach company, H-A-C-H.
H-A-C-H, okay.
And you can purchase these from industrial supply houses like McMaster Car or things like that.
Sure.
They will give you ppms of water. You heard a lot of old timers always talk about crackle tests. And that is not a good way to determine how much water is in there. Our studies have shown that you can get as much as 1,000 to 1,500 ppm of water before that oil starts to crackle. And the way you run a crackle test is you take a hot panel that's hotter than the boiling point of water.
Yeah.
Put a couple of drops of oil on it, and if it crackles, there's water in there.
Gotcha.
Sometimes the oil is so thick, it doesn't really crackle, and you can't see it until you get too much water in there.
Yeah.
The way all quench oil providers do it in their lab is something called a Karl Fischer titration. And this is not something that the typical heat treater would have in their lab. It's a relatively expensive piece of equipment, but we use automated ones, and because we do so many at a time, but you can buy manual ones if you'd like, and those are a little bit less expensive. But again, you're talking about laboratory equipment, and you're talking thousands of dollars instead of hundreds of dollars.
Yeah.
Another way to determine if you have water in your quench oil, especially on lighter colored quench oils, is to take a flashlight, put it in a clear beaker, and take a flashlight and put that flashlight at the bottom of the beaker.
Okay.
If nothing in that beaker is hazy and everything is very clear and amber and you can see through it, chances are there's no water in it. But if it's a dark quench oil, like a lot of cold oils are, where it's almost jet black,
yeah,
the flashlight won't do you any good.
Not going to do any good. Okay.
And then there's also one of our customers has talked about using a paste. And I unfortunately don't know the manufacturer of it, but what he did is he took a paste and put it on a wooden stick and stirred it all throughout his tank. The paste didn't turn colors, so he knew there was no water in it. And to prove that the paste was still good, he actually licked a finger and put it onto the paste, and the paste turned pink.
Okay. So this paste is, you put it on the stick and you put it in, it doesn't dissolve into the liquid. It's just testing whether there's water there.
Correct.
We'll get back to Greg and Doug in just 1 second, but first, are you a part of a forward-thinking team, or are you looking for resources to help you understand cutting-edge technologies in heat treat? If so, you have to check out the free ebook, High Pressure Heat Treatment, Leading the Renaissance of Hot Isostatic Pressing. This short resource is provided by Heat Treat Today through a partnership with the great people over at Quench Technologies. In High Pressure Heat Treatment, Leading the Renaissance of Hot Isostatic Pressing, you'll learn critical, basic knowledge about high-pressure heat treating, as well as where the technology is going. Download High Pressure Heat Treatment, Leading the Renaissance of Hot Isostatic Pressing to find out more. Again, your copy to freely download is at www.heattreattoday.com/ebook. Now, back to the episode.
Probably the best method, you're saying most reasonable method that doesn't cost so much is maybe getting one of those kits from one of the kits of testing. How do you have suggestions, Greg, on how frequently a heat treater ought to be checking his tank for water, his or her tank for water?
I would say weekly. I don't think it needs to be tested anymore unless you think there's a problem. If there's a problem, obviously test it as often as you need to.
Yeah.
But weekly is good enough. When you're dropping a load into Quench oil, you're anywhere from 1,300 to 1,800 degrees Fahrenheit.
Yeah.
So when you drop that load and you're driving almost all of the water off that would be in the Quench oil from condensation, if you're worried about some sort of a human error, that's when you want to take more frequent testing.
Yeah. So it's going to be somewhat dependent on your process. How about the material that you are quenching? Is there any? I mean, are some materials more sensitive to water than others, or is it not really an issue?
Not really. It's more of an issue of part geometry.
Okay.
And that goes really for distortion and cracking along with the water. And a little bit of water can crack a very thin part, but on a very thick part, it may not have much effect at all.
Yeah. And how about cosmetics? I know that some people are very concerned with cosmetics. Is water into Quench oil going to cause any issue with cosmetics? Spotting or?
Short term, no. Long term, yes.
Okay.
What causes a lot of stains is oxidation.
Right.
And water, when it heats up, will actually dissociate into hydrogen and oxygen.
Yeah.
The hydrogen won't oxidize the oil, but the oxygen does.
Right.
And that's one of the reasons why heat treaters use flame curtains, not to allow the oxygen from the atmosphere into the furnace.
Sure.
At the temperatures that you heat treat at, it doesn't take much oxygen presence to oxidize not only the parts, but also the oil. Okay,
gotcha. Yeah, good. All right, so Greg, we talked briefly about why water is a problem. We talked about measuring it and trying to determine if you have an issue. So let's move on to this. Let's say, okay, we've measured, we've got water in the Quench and it's at an unacceptable level. What do we do?
There's a few ways to do it, and it really depends on what level water you're at, how safe you feel, and how soon do you need that furnace. Many furnaces have a bottom drain. So if you turn the agitation off in the Quench oil,
right,
the water is going to be heavier and more dense than the oil, and it will sink to the bottom. This is going to take a couple of days at least.
Okay.
And if you're looking at 1,000 ppms or so, this is probably the best way to do it, because then you can drain from the bottom of the tank until you no longer see water coming off and you see oil. Let's say you've got 500 ppm or 400. We recommend an upper limit of 200. For that, you can run some scrap through your furnace. Again, you have to be very careful because you're not really at what would be an explosive level, but you don't want to run good parts through there because you may get some strange hardness results. They may be higher in hardness than what you're expecting. Another way, again, this will take some time, is to actually bring the temperature of your oil above the boiling point of water.
Yeah.
So if you brought it up to about 220 degrees or so, you would, as the oil starts to evaporate, you'll see bubbles and a froth, almost like a head of you would see on a beer.
Right.
Come to the top of the oil tank. Once that's gone, chances are your water's gone.
Yeah.
And then the last thing that you can do is do a complete dump, drain, and recharge.
Yeah.
But I would caution anybody who suspects that they have water in their quench oil and you want to do any of this testing, before you run any loads through that furnace with good parts, make sure you send a sample overnight to your quench oil provider and they can test it for you. That's the biggest issue.
Yeah. I want to back up. You said something I didn't catch the fullness of it. I don't think you said one of the solutions was to simply run scrap parts through your furnace.
Yes.
How does that help you eliminate the water?
Again, you're taking these scrap parts and they come through your furnace, and the furnace may be 1800, 2200 degrees.
Yeah.
So when you dump that load into the quench, if you've got just a small amount of excess water, it'll evaporate off.
So you're basically bringing up the temperature of the oil. So in a sense, bringing up the temperature of the oil so it evaporates. Gotcha.
Exactly.
Okay.
You're almost flashing it off.
Yeah. Okay, good. All right. Yeah, I think that's good. Now, I know of some companies that we talked about the draining and the replacing. I know some companies recycle their oil. Any thoughts or comments about that that heat treaters ought to be aware of?
Yes, because that's also a potential source of contamination for water.
Okay.
Because they skim that water, or they skim the oil off of their cleaner tanks.
Yeah.
And I've been in a lot of heat treaters that have, these reclamation systems. They heat the oil up. Theoretically, they drive all the water off, but not always.
Right.
And again, this is part of that human error. And as a quench oil company, we understand that our customers are doing this, especially with oil continuing to go up. But again, working with your quench oil supplier here is key, because we'll analyze the samples for our customers and tell them if they're getting all that water off.
Okay.
Because obviously it's in the quench oil supplier's best interest and the customer's best interest to make sure everybody is safe.
Yeah.
Now, if a plant burns down, nobody wins.
Yeah, very true, very true. So this is helpful. So we discussed basically, why water is a problem, how do we measure it to make sure we know it, and then what to do with it. Do you have, Greg, being the kind of the quench expert, being a quench expert, do you have any other resources if someone was interested in learning more, whether it be specifically about water and quench oil or just other quench resources? Anything you can recommend for further reading?
Wrote a series of articles on quench oil and how to get quench oil or water out of the quench oil for your publication, Heat Treat Today.
Okay.
Also, how to use your analysis from your quench oil supplier to operate your furnace. You should always let the data tell you how to operate a furnace.
Yeah.
And not do something just because we've always done it this way.
Yeah.
Others, such as Scott McKenzie, have presented papers. I know at Back in 2018, there was a conference, Thermal Processing and Motion by ASM.
Yep.
He presented a paper there on how to get rid of water out of a quench oil.
Any other resources you'd like to recommend to people?
Yeah, use your quench oil supplier.
Yeah.
They're the experts. They're the ones that have all of the testing equipment you need, and use them as a resource. And
Yeah.
if they, quite frankly, if you don't get the service from your current quench oil supplier, there's a bunch of us out there, and
Yeah.
that's how we distinguish ourselves, is through our
Sure.
service, and find somebody with better service.
Yeah, there are a number of quench oil suppliers out there. I know some of them are not really specifically targeting the heat treat market, but people still use them because they're a local distributor or something like that. I think I want to recommend to people that if you're having trouble with the processing of parts, whether it be the mechanical properties, things of that sort, and you have a hint that it might be quench related, probably best to get a hold of people like Greg, who are actually focused in more on the heat treat market. They may have some good recommendations. So yeah, just a kind of an encouragement there to people. If you're not using a heat treat specific quench company, there are a couple of them out there. And obviously Greg with Idemitsu, we appreciate you giving us a little bit of expertise today. So yeah, thanks very much, Greg. Appreciate it. Appreciate you being with us. And I think that'll be great.
Thanks for your time, Doug. I appreciate the opportunity.
We hope you enjoyed listening to today's episode with Greg Steiger. Heat Treat Radio is on Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to get in contact with Greg, head over to www.ilacore.com or call him at 919-935-9910. You can either email him at gsteiger, that's STEIGER, .9910@idemitsu.com, or you can reach out to me and I can put you in touch. My email is bethany@heattreattoday.com. Do you have a new or interesting idea that you want to hear discussed next time on Heat Treat Radio? If so, let me know. Also, if you'd like to sponsor a future episode, you can let me know at bethany@heattreattoday.com. Heat Treat Today has been busy planning the first ever Heat Treat Boot Camp in Pittsburgh this fall. If you enjoyed this podcast, but maybe you want to get a better handle on heat treat industry broadly speaking, you can sign up for this 2-day event at heattreattoday.com/bootcamp. There's also a lot more info at this event's webpage, so you can read all about those details when you go there. Heat Treat Radio would like to thank High Pressure Heat Treatment, leading the renaissance of hot isostatic pressing, for supporting this episode. Get your free ebook today at www.heattreattoday.com/ebook. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. And I'm Bethany Leone. Thank you for listening.